look at this image, there are lots of splodges all over the place. What made you look at that one in particular?
That splodge here. So it's really probing basically the earliest structures we know in the universe.
The James Webb Space Telescope has once again stunned the scientific community by capturing data that many astronomers believe could hint at something far more mysterious than we have ever imagined. For decades, cosmologists have worked under the assumption that our universe began with the Big Bang, a singular explosive event that marked the beginning of time and space as we know it. But what if that assumption is incomplete? What if the universe we see around us is not the first, but merely one in a chain of countless universes that came before? Nobel Prize-winning physicists are now daring to suggest that recent discoveries by Webb might be pointing toward the existence of a universe before our own. The telescope's unparalleled ability to peer deep into cosmic history has revealed patterns, anomalies, and structures that current models cannot easily explain. Instead of confirming the neat timeline of cosmic evolution, these discoveries are shaking the very foundation of physics, suggesting a far more complex and cyclical picture of reality. From its position a million miles away at Lagrange Point 2, Webb is designed to look deeper into space and farther back in time than any telescope in human history. By capturing faint light that has traveled for billions of years, Webb is effectively acting as a time machine, showing us what the cosmos looked like mere hundreds of millions of years after the Big Bang. But what has astronomers perplexed is that instead of the small, primitive galaxies they expected to find, Webb's detectors have spotted enormous, fully formed galaxies appearing almost immediately after the supposed birth of the universe. According to standard cosmology, this should be impossible. There simply wouldn't have been enough time for matter to coalesce into such massive structures. Yet the images and spectroscopic data are undeniable. Galaxies containing billions of stars seem to emerge almost instantly out of the cosmic dawn. This strange reality has led some leading scientists to conclude that the Big Bang may not have been the absolute beginning after all. One of the most shocking pieces of evidence came when researchers studied the background radiation that fills the universe, known as the cosmic microwave background, or CMB. This faint glow is believed to be the afterlight of the Big Bang, stretched across space by billions of years of expansion. But Webb's instruments are now revealing subtle patterns in deep-field images that don't align with predictions made by the Big Bang model. Nobel Prize winner Roger Penrose has long argued that these anomalies could be the result of something profound, traces of a universe that existed before ours. According to his controversial theory of conformal cyclic cosmology, the universe is not a one-time event, but an eternal cycle, where each Big Bang is simply the rebirth of the cosmos after the death of a previous one. He suggests that what Webb might be detecting are fossil imprints of structures left behind from that earlier universe, echoes from a time before time. This claim might sound radical, but it is not without growing support. Many astronomers who once dismissed such ideas are now reconsidering in the face of Webb's data. The discovery of massive galaxies at impossible distances is forcing a scientific reckoning. If galaxies formed so quickly, either the physics of galaxy formation is far different from what we thought, or the universe itself had a head start, one that might extend into a pre-Big Bang era. Even more perplexing are the bright objects Webb has spotted at extreme distances that do not seem to match the characteristics of galaxies at all. Some scientists have speculated that these could be remnants of structures from an older universe, bleeding through into ours in ways we cannot yet comprehend. Adding to the mystery, gravitational lensing, the phenomenon where massive galaxies bend and magnify light behind them, has revealed repeating patterns in Webb's observations. Some experts believe these patterns are too regular for being random chance. Instead, they might be signals of a deeper, hidden order in the universe, one that could be explained if our cosmos was preceded by another. If true, this would rewrite the narrative of cosmology from one of a singular beginning to one of endless renewal. The idea that our universe could just be one chapter in an eternal story is both humbling and staggering. Nobel Prize-winning physicists are not taking this lightly. They caution that extraordinary claims require extraordinary evidence. Yet the weight of the data is undeniable, and it is forcing the scientific community to entertain possibilities once thought too wild to discuss openly. This has also led to renewed debates about the nature of time itself. If the universe is cyclical, then time may not be a straight arrow moving from past to future, but rather a looping cycle with no true beginning or end. In such a model, the death of one universe gives rise to the birth of another, with each cycle erasing the details of the previous one but leaving behind subtle traces. These traces, proponents argue, are what Webb might now be uncovering. The possibility that humanity is peering into the last dying breaths of a previous cosmos has electrified the scientific world. Some are even calling it the biggest paradigm shift since Einstein's theory of relativity. But the implications do not stop there. If another universe did indeed exist before ours, then the laws of physics themselves may not be fixed constants. Instead, they might evolve from cycle to cycle, subtly shifting as each universe gives way to the next. This could explain why certain cosmic parameters appear finely tuned for life in our universe. It may not be coincidence, but rather the product of countless cycles, with only universes capable of supporting complexity surviving long enough to produce observers like us. Webb's discoveries are therefore not just challenging our timeline of cosmic history, they are forcing us to reconsider the very meaning of existence and reality. The more Webb sees, the more the questions multiply. Every deep field image it returns seems to add to the growing puzzle. Astronomers expected to find simplicity in the early universe, small, dim galaxies slowly forming from clouds of gas. Instead, they are finding complexity, brightness, and abundance where none should exist. For some, the only logical conclusion is that what Webb is showing us is not the first universe at all, but a continuation of something far older. Others argue that we may simply be on the brink of a new physics, unknown forces and particles that allowed galaxies to form faster than we thought possible. Either way, the message is clear. Our understanding of the cosmos is incomplete, and Webb has only begun to peel back the layers of mystery. As researchers scramble to interpret these baffling results, the debate within the scientific community is becoming increasingly intense. Some scientists argue that we must be cautious before discarding decades of well-established cosmology. They point out that the James Webb Space Telescope is still in its early years of operation, and calibration errors, data misinterpretations, or limitations in our current models of stellar evolution could be leading to exaggerated claims. Yet the counterargument is growing louder. The sheer number of anomalies cannot be brushed aside as coincidence or error. When Webb first detected massive galaxies forming only a few 100 million years after the supposed Big Bang, many skeptics insisted this must be a fluke. Now, with repeated confirmations and dozens of independent teams reporting similar results, those skeptics are running out of explanations. The data is real, the images are real, and the consequences are potentially revolutionary. The scientific method demands we follow the evidence, no matter how unsettling the implications may be. One of the most striking findings comes from spectroscopy, the study of light broken down into its component wavelengths. By analyzing the spectra of these early galaxies, astronomers can measure not just their distances, but also their chemical compositions. To their astonishment, many of these galaxies already show signs of heavy elements, like carbon, oxygen, and iron, elements that should not exist in such abundance so early in cosmic history. According to current theory, the first stars were made almost entirely of hydrogen and helium, with heavier elements forming only after generations of stars lived and died in supernova explosions. This process should have taken billions of years, yet Webb's data suggests it may have happened almost immediately. Some astrophysicists suggest this points to an earlier cycle of star formation, possibly evidence of material left over from a previous universe. If true, the chemical fingerprints Webb is detecting could be the ashes of a cosmos long gone, scattered like cosmic fossils across the new one. Nobel laureates such as Roger Penrose, who has been championing the idea of a pre-Big Bang universe for years, are feeling vindicated. In his conformal cyclic cosmology theory, each universe begins where the previous one ended, in a smooth transition where the infinitely stretched-out end of time becomes indistinguishable from the next beginning. In this picture, the Big Bang is not a singular creation event, but merely a transformation, like a phoenix rising from its own ashes. Penrose has long claimed that traces of black holes from a previous universe could be found as patterns in the cosmic microwave background, what he calls Hawking points. Until now, these claims were controversial at best, but with Webb revealing unexplainable structures and galaxies too mature for their supposed age, more and more scientists are starting to wonder if Penrose might have been right all along. What was once fringe is now entering the mainstream of cosmological debate. Equally fascinating are the philosophical implications. If universes arise in cycles, then what does that mean for concepts like time, causality, and existence itself? Imagine a cosmos with no true beginning and no final end, a reality where each universe is just a chapter in an eternal book. In such a framework, the question, what happened before the Big Bang, has an answer. Another universe did, and before that, another, stretching back infinitely. The human mind struggles to grasp such infinity, but Webb's discoveries are forcing us to confront this possibility head-on. For some, this raises profound existential questions. Are we living in just one of countless iterations, with everything we know destined to be erased and reborn? Do laws of physics repeat exactly each time, or do they change slightly, creating new possibilities and perhaps even entirely different forms of matter and life? If time is cyclical, perhaps even consciousness itself might echo across universes, though this remains speculative and deeply controversial. While some scientists welcome these ideas, others warn against leaping too quickly into metaphysical speculation. They argue that extraordinary claims require extraordinary evidence, and so far Webb has provided tantalizing hints but not definitive proof. It is possible that our models of dark matter and dark energy, the invisible components that make up most of the cosmos, are incomplete, and adjusting these models might explain the anomalies without requiring another universe. Others propose that unknown processes of star formation or exotic physics at high energies could account for the rapid appearance of galaxies. Yet even these alternatives point to one undeniable truth: our current understanding is woefully insufficient. Whether it means revising the Big Bang model, rewriting the laws of physics, or embracing cyclical cosmologies, the path forward will require a fundamental rethinking of everything we thought we knew. Webb has also intensified the discussion around the so-called cosmic horizon. This is the maximum distance we can ever hope to observe, beyond which light has not had time to reach us since the beginning of the universe. For decades, cosmologists assumed that what lay beyond this horizon was simply more of the same: galaxies, clusters, and dark voids extending infinitely. But if Penrose and others are correct, beyond the horizon might lie not just more universe, but the remnants of an earlier one. In other words, the edge of our vision might be brushing against the fingerprints of a prior cosmos. Some theorists have even suggested that gravitational waves, ripples in space-time caused by violent events like black hole collisions, could carry information across universes. If Webb or its successors ever detect such signatures, it would be the closest thing to direct evidence of a universe before ours. The prospect is breathtaking, raising hopes that one day we may truly know if reality itself is cyclical. And yet, for all the bold theories and cosmic speculation, the James Webb Space Telescope remains first and foremost a machine of discovery. Its gold-coated mirrors and sensitive instruments were not designed to confirm or deny the existence of previous universes, but to answer practical questions about galaxy formation, star birth, and planetary atmospheres. That its data has inadvertently cracked open the deepest mysteries of existence is a testament to the power of human curiosity and engineering. Scientists are not yet ready to declare that Webb has proven another universe existed before ours. But one thing is certain: the telescope has opened a door that cannot be closed. The universe is stranger, older, and more complex than we ever dared to imagine. The coming years will determine whether these strange anomalies are the first glimpses of a deeper truth, or simply puzzles that will yield to new physics. Either way, the journey has only just begun, and humanity stands at the threshold of a new era in cosmology.